Hello. Welcome to the live show. Another week, another show. So many of these. I don't even remember how many. Let's just say 300-ish. We're probably around that anniversary that we need to have a little party. Welcome to the show. I am Bret, and Nirmal is gone this week. I'm excited because we're going to talk about something new in Kubernetes that K8s has built, and I'm excited to get into that. But first, before we do, thanks for being here for the live show. What am I? Who am I? Why am I here? Well, you can join our DevOps server. I think it's the largest DevOps server on Discord. If you're interested in Discord chat, we're in there every day, like 25,000 people. Just join us. Where people are learning DevOps, learning how to use AI with platform engineering and cloud and DevOps and all that stuff. That's obviously a very hot topic lately. And we just have a lot of fun in there. And you can join the conversation, learn from other people. We also have meme channels because if you can't do without your tech memes. So that's an important thing for the community that we provide. Thanks to those that support that group. And we have podcasts. So this show, the reason we're recording it live is so that you can ask questions of my guests and figure out what you need to know if you're interested in the particular technology we're talking about. Of course, we talk a lot about Docker and Kubernetes here, but if you didn't know, we have a little podcast that comes out of this. So you can go over to podcast.bretfisher.com, or I will send in the link so you have that. And because one podcast is not enough, we also launched a new podcast this year called Agentic DevOps. So let me give you that link as well. That is our new podcast. The specifics are that it's just about how people are using AI to do the work of DevOps, platform engineering, SRE, operations. And that is a very new field for us to trust the AIs with, right? So it's a new innovation in the world of AI. We were all using AI to code at first and using it to answer our random questions, but now people are actually starting to use it to automate infrastructure and to help troubleshoot and to do CI/CD. So come check it out. Our last episode was one from Laura Taco. She's been on the show many times before. It is honestly one of my favorite shows of the year. You really should check this one out. I feel like the message she's putting out and the conversations we're having are pretty rare right now. I think everyone's going to be having these conversations in the next 6 months, but it's a great conversation about the real world data coming out of analysis of hundreds of companies on whether AI is actually helping them be more productive as software developers. It's a very good question, and she luckily has the metrics and the data and the analysis to show the stats. And of course, the stats are mixed. So please check that one out. I'm very excited about that. It's on Agentic DevOps. You can find it anywhere on the internet, on YouTube, on any of the podcast players. That's one of my favorites of the year. And then if you didn't know, I am launching a new course here eventually, soon-ish. So you can jump on that. That is a course. These are going to be courses on GitHub Actions, including one on CI with AI. So we're going to learn how to throw AI into GitHub Actions to do some of the work, whether it's analyzing the comments or the PR, or whether it's maybe actually deploying infrastructure or telling you that your Terraform is horrible, like it likes to tell me. So that's a thing, and you can join for that. Well, enough about my stuff. Let's get to I was muted. Hello, gentlemen. Welcome to the show. Thanks for waiting.
Hey, Brett.
All right. Let's do some introductions before we get started. And I am obviously wearing the wrong shirt today. We did not organize ahead of time what color we were going to wear. So apologies. I do have a blue shirt. I should have worn it. In the middle there, we've got Philip Andrews. Both of these gentlemen are from Cast AI. Philip is the global field CTO at Cast AI, and I don't know if that means if you live on the globe or if you travel the globe. What exactly does global CTO do?
It seems like a little bit of both these days. Working with a lot of our large customers, a lot of the strategic partnerships, usually new technologies. So working with a lot of our customers on showing them new technologies, helping them proof of concepts with new technologies. So it's been kind of a cool role. It's basically on the technical customer facing side. So I get to do a lot with our largest customers and solving some of the hardest problems.
Nice. When you don't know what the title is, it makes it sound like you just live in an airplane. It sounds impressive. On the right over there, we've got Dan Muret or Muret. I really don't know my French, so that's probably a horrible pronunciation. Dan is here. He's the senior sales engineer with Cast AI, or one of them. I'm going to make you the senior sales engineer so that you sound very elite. Welcome, Dan.
Thank you.
We're going to get into it. So we were previously before the show, we were talking about mountains and travel and vacations, and we've all evidently this year had some wonderful time exploring grass and touching it. So I feel like I don't feel so bad making you sit on this blue screen interface for too long because we actually got outside, and that's a great thing to do. What who could tell me about what's like the elevator pitch for Cast AI? Because I've known about you all for years. I've visited your booth at KubeCon at least a half a dozen times over the years. What's the main benefit of Cast AI?
Sure, I can grab that one. So when Cast AI was originally founded, it was founded to solve a problem that our founders had in their last startup years ago, which was every month their AWS bill was going up 10%, regardless of what they did the month before to try to mitigate and manage costs across the infrastructure. So when they sold that as startup to Oracle, when they finished that startup, they went when they finished that Oracle time, they went and figured out how to solve this problem. They said, well, Kubernetes is going to be the future platform. We're going to make our bet on Kubernetes. And the only way to solve this problem is through automation because doing things manually every month, one, it's tedious and takes up a lot of time. And two, it's not helpful, right? You save a little bit every, it's two steps back for every step forward you make. With Cast AI, it's fully automation first, right? We made the effort that everything was going to be automated from the start. And so when it comes to node auto scaling, node selection, node right sizing, workload right sizing, everything to do with Kubernetes, everything we implement is automated. And that's where kind of the live migration piece came in, was being able to automatically move applications around within the cluster without having downtime. And that's where application performance automation comes in, is moving from this application performance monitoring mindset. And Datadog has made a lot of money on that. I don't know if I'm allowed to say that. But they've done very well, and they have a fantastic platform. We love Datadog. But you get data overload. You end up with metric overload, and actioning on those is very hard. Where we need to go from here, especially with the AI mindset that we're moving into, is automation of that application performance, and that's what Cast AI is leading the way in.
Nice, nice. I mean that when you all reached out and I learned about the fact that you now have live migration, it took me it flashed me back to almost 25 years ago when that was sort of first invented for VMs. And at the time, it felt like magic. It did not seem real. We all had to try it to believe it because it seemed impossible to move from one host to another, maintain the IP, maintain the TCP connections. How do, like, surely I'm going to freeze up and it's going to be like a frozen screen. Like, we all just assumed that, and then eventually, and maybe at first it was a little hiccupy. I think if I remember correctly, like 2003, 2005, it was one of those where it wasn't quite live, and it was like very, very short amounts of gaps, and then eventually it got good enough that it was live. And I was running data centers for local governments at the time, so I was very interested in this because we were running both ESX and Hyper-V. So I was heavily invested in that feature and functionality. So when I saw that you all were doing it to Kubernetes, my first thought was, why did this take so long? Like, why don't we have this yet on everything? Because it's clearly possible. Like, it's technically possible. Obviously, it's not super easy, and it requires a lot of low-level tooling that has to understand networking and memory and disk writes and all that kind of stuff. So I'm excited for us to get into exactly how this sort of operates for a Kubernetes admin, and I really feel like this show is going to be great for anyone learning Kubernetes or Kubernetes admins, because to talk about the stateful set, the daemon set problem of, we've got stateful work. Everyone I know almost has stateful workflows in Kubernetes. I would say, I don't know about you all's experience, but to me, it's an exception when everything is stateless in Kubernetes nowadays. Do you find that to be the case?
Yeah, absolutely.
Dan?
I mean, yeah, we talk to customers all the time, right? And yeah, used to, just a couple of years ago, right? It was a lot more stateless, right? Web servers, whatever. And now we're definitely seeing a shift to, more stateful workloads, in that, whether it's, legacy applications that are being forced into Kubernetes as part of a modernization project or whatever, we're seeing a lot more stateful workloads in Kubernetes for sure.
Yeah, it's
particularly amongst the Fortune 100s, Fortune 500s, right? Because you've got this modernization, and I put it in quotes, where modernization means taking some crusty old 15-year-old application, containerizing it and shoving it in Kubernetes and calling it cloud native, the flawed approach of lift and shift. Um, and you end up with a lot of applications that are in Kubernetes, they're listed as a deployment, but you can't restart them without your customer having a significant outage.
Right.
Like it
Right.
goes against everything Kubernetes was built on. But that's the world we live in today. When we first launched live migration and I posted about it on LinkedIn, some of the first questions I got was, why is this even needed? If you're doing Kubernetes correctly, live migration shouldn't even be a real thing. I'm like, yes,
Right.
but 95% of the customers I deal with don't do Kubernetes, quote unquote, the right way.
Well, yeah. I mean, I honestly think that we could argue that that's a great point. And I think like the vision originally, like when Docker and Kubernetes were both created, it was like stateless because it's easy. Like, move everything around. It's wonderful. But I think that I mean, this channel, if there's anything consistent about this channel over the almost decade that it's existed, it's that it's all containers. Like, I don't care what the tool is, we're doing it in containers. And to me, the large success of containers is because we could put everything in it. Like, it is not, you don't have to rewrite. I mean, so many evolutions or attempted evolutions in tech have been, well, you're going to have to rewrite to, functionless, functions, you're serverless. You're going to have to write functions now, or you're going to have to rewrite this language or whatever. I'm going to pause for the jet noise. Okay. And that's, I think that's like the secret sauce of containers was that we could literally shove everything in it. It's also the negative. And so there's a thing that, I don't know if I learned it from a therapist or whatever, but often our weaknesses are just overdone strengths. And I feel like containers, the strength of containers is that you can do everything with it. You can put every known app on the planet in it. They will eventually work if you figure it out. But the overdone weakness of it is that we're also putting everything in there, which makes managing these infrastructures very hard, because you have to assume everything's fragile until you are sure that it's truly stateless. And even stateless, people say stateless, and what they really mean is it doesn't care about disk, but it definitely cares about connections, which is
Yep.
when we're trying to talk about stateless, that's not technically accurate. Like when we say stateless, we should probably mean also doesn't care about connections, at least once the connections are drained. But it's an interesting dilemma we all have in infrastructure of like, yeah, we have the power to be able to move everything and do everything, but also everything's super fragile that we're running at the same time. So how do we even manage that? So
We've encountered a lot of teams that swore up and down they were stateless right up until you started bin packing their cluster. They
Right.
said, wait. Why are we having all these restarted pods? We're like, because we're bin packing and we're moving things and we're compressing and we're getting better, optimization. They're like, but my container restarted. Well, yes, that's what containers do in Kubernetes.
Right. And for those that are maybe just getting into Kubernetes or haven't dealt with large enterprise forever workloads where they just can't be touched. I've had 30 years in tech of don't touch that server, right? Don't touch that workload. It's fragile, it's precious, but it's also probably on the oldest hardware and the least maintained. So the idea of one of the performance measures that I think any significant sized Kubernetes team is dealing with is the cost of infrastructure. And then we keep getting told, I think this was just in the last year at KubeCon, that even on top of Kubernetes, we're still only averaging like 10% CPU on average utilization across nodes. Like we still are struggling with the same infrastructure problems that we were dealing with the last 30 years, even before VMs, before virtualization. That was the same problem we had then because everybody would want their own server and they always had to plan for the worst, busiest day of the year. So they would buy huge servers, we'd put them in, and then they'd sit idle almost all the time because they barely got 5% utilization. So I can see where like one of the core premises of something like an application performance tool is that we're going to need to save you tons of money by bin packing. So can you kind of explain sort of the bin packing process? Like, what does that look like?
Sure. So one of the big things with Kubernetes in general is the scheduler will typically round robin assign pods to nodes. So if you have 10 nodes in a cluster, your pods will more or less get sort of evenly distributed to those nodes in the cluster. Yeah, you can manage that with certain different scheduler hints and certain scheduler suggestions to be able to steer that towards most utilized, least utilized, etc. But at the end of the day, you're going to have spread out workloads across your nodes. bin packing is basically the defragmentation of Kubernetes, right? Back, Brett, when you were first starting out, when I was first starting out, and you could actually defragment a hard drive and you get to move the little Tetris blocks moving around the screen, which good
Good
old
days.
days.
Good
Um,
days.
being able to do that in a Kubernetes cluster can mean massive, massive savings on the actual utilization of that cluster because now you free up a bunch of workloads, a bunch of nodes in the cluster that are no longer necessary. You can delete those off, and when you need them, you just add them back. That's the joy of being in a cloud environment is you can use the least amount of resources when you don't need them. So in, for instance, at your off busy hours, your nighttime hours, and then when you start needing them again, you spin them up, you add more to it, you scale up during the day, and being able to do that process over and over again every day is how you can optimize kind of your cloud resources. What we see is that people have so many stateful workloads, and whether it's stateful in real statefulness or stateful in this is a really poorly architected application, or stateful in this application takes 15 minutes to start up and it's monolithic and I can only run one copy of it, so I can't move it. All of those things cause it so you can't bin pack a cluster, right? You can't move those things around. So what ends up happening is people just end up with these stateful workloads scattered throughout all 10 nodes, and even if the 10 nodes are only 60% utilized, you can't get rid of any of them because it'll cause some kind of service interruption. And that's where live migration allows you to actually move those stateful sensitive workloads. Now you can bin pack. So now those 10 nodes can go down to 6 or 7 nodes without having a service interruption, even if there's less than ideal workloads scattered throughout the cluster.
Yeah, I was just typing in the chat. We're having a conversation in the YouTube chat around like stateful versus stateless versus like where is the scenario for where we need a live pod migration, and like to those that are perfect in all their software and they run and they control all the software that runs on Kubernetes. I don't know who those people are, but let's just say they exist. Then in theory, this isn't needed. Every database has a replica, has a database replica or database mirror, so you can always take a node down. Every pod properly has proper shutdown for ensuring that connections are properly moved to a new pod. By the way, I used to do a whole conference talk on just like TCP packets and resetting the connection to make sure it moves properly through the load balancer to the next one, and having a long shutdown time so that you can drain connections, and if you have sticky and all these different that world of shutting down a pod is so more complicated than anyone gives it. Like everyone treats it like it's casual and easy, and it's just so not. Like if you're dealing with hundreds of thousands or millions of connections, there is a lot of nuance and detail to this. So I often end up with teams where they implement Kubernetes. It's like a sort of predictable pattern, right? They implement Kubernetes, they move workloads to it. They think that somehow Kubernetes gives their workloads magic, and then they just start trying moving things around, and they realize when their customers complain that no, the rules of like TCP and IPs and load balancers and connection state, like all these rules still apply. And so you really have to understand those lower levels. And obviously disk and writing to disk and logs for databases and all that stuff. Like that's still there too. I think the networking is the part where I see a lot of junior engineers sort of hand waving over it, because quite honestly, the cloud has made a lot of the networking problems go away. So we don't have to have Cisco certifications just to run servers anymore. We used to, but now we can kind of get away with it till a certain point, I feel like, in the career or complexity level. And then suddenly you're now having to really understand the difference between TCP and UDP, and how session state or long polling or WebSockets, how all these things affect whether you're going to break customers when you decide to restart that pod or redeploy a new pod. And I love that stuff because it's super technical, and you can get really into the weeds of it, and it's not I wouldn't call a solved problem for everyone. So my understanding of something like a live migration is it actually takes all of those or most of those concerns. It doesn't make them irrelevant, but it does deal with those concerns. Am I right? Like in terms of networking, we're talking about live migrations having to be concerned with IPs and connection state, stuff like that.
Go ahead, Dan. You want this one?
Yeah, go ahead.
Yeah, so with being able to do the networking move of things, that's to your point, reestablishing those sessions. One of the big things we see is long running jobs. So if you've got a job that's running for 8 hours and it gets
Yeah.
interrupted at 6, now you've lost that job.
Yeah.
Even if you try to move it from one to, there's some checkpointing and stuff involved. A lot of times, like on a Spark workload, the driver will just kill the pod and restart it if it senses any kind of interruption in the networking. So the networking is super important there, being able to maintain that.
Hmm.
Long running sessions, WebSockets, to your point, we've actually tested this extensively with WebSockets. WebSockets stay connected, right? And we're still in kind of those early vMotion days. There is a slight pause when we move things.
Yeah.
It took vMotion multiple years before they got it kind of really ironed out. We're moving probably faster than them because we have a lot of experience, of the experiences they went through, and this research that's happened since then. So I think we're moving pretty fast on shortening and shortening and shortening that time window. But there is a slight pause. But what we found is you queue up all the traffic, and then once the pod is live on the new node, that pod traffic is replayed and all the messages come through. So even on something like a WebSocket, you don't actually lose messages. They're just held up for a few seconds.
Right.
And that's extremely important for maintaining that connection state, like you were mentioning. One of our customers that we're working with this heavily on, they run Spark streaming jobs. So they're 24/7, 365, pulling off a queue, running data transformations and detections, and then pushing somewhere else for alerting mechanisms. If they have a pod go down, it takes them about 2 minutes to get that all restarted, get that process restarted, pull in all
Right.
the data that they need again. That's 2 minutes of backlog. They have super tight SLAs. They have a 5 minute SLA from message creation to end run through the entire detection pipeline. And that's including all of the steps involved there. So if you've got a 2 minute delay on that shard in your Kafka topic, now that's a huge chunk of that 5 minutes that you just ate up. You're
Right.
talking all the other pipeline. It's very easy to start missing SLAs there. It's You can't take maintenance windows. If you're 24/7, 365 and you're doing security processing, you can't be like, well, security is going to be offline for 10 minutes while we move our pods around. Like, that's not acceptable in that world mindset.
Right.
So keeping that connectivity, keeping the connection state, being able to keep everything intact, keeping the Kafka connection, keeping the Spark driver connection is all super important with being able to move that entire TCP/IP stack over from one node to another during that migration process.
Yeah, and I mean, we're really talking about a lot of the different kinds of problems that come with shifting workloads at willy-nilly. Like that's if that's the technical
Yep.
term, willy-nilly. Like being able to say, walking into an environment and sort of being your own wrecking ball and your own chaos monkey and saying, which I'm going to go over here and push the power button on this node, or I'm going to properly shut down this node. Do you have everything set up correctly so that connections are properly drained and all the like that is such a sort of I would say a moving target, especially because every time we've had these kind of processes where I've had clients where we go through this like exercise of we're going to do maintenance on a node and we're even going to plan for it, and then we do it, and then we fix all the issues of the pods and the shutdown timing and the Argo CD deployment settings that we need to massage and perfect. And then 6 months later, if we do it again, the same thing happens because now there's new workloads that weren't perfected and weren't well tested. And if I can make a career out of actually being like a pod migration guru, like that sounds like my kind of dream job, where we crash and break everything, and then we track all of the potential issues of that, and we are like a tiger team that goes pod by pod and sort of certifies it as like, yep, this pod can now move safely without risk because we've got everything dialed in, we've got all the right settings, and I feel like that's a workshop opportunity. I feel like I need to maybe sell something on that because there are so many levels of complexity. We haven't even talked about like database logs and database mirroring and how you can't really spin up a new node of a database and let it sit there idle as a pod while you're waiting for the old one to shut down. They can't access the same files, blah, blah, blah. Like it just depends on the workload, on how complex this all gets. But I'm assuming also that when we talk about something like live migrations, we're not just concerned with networking, we're also somehow shifting to storage as well. I'm guessing there's like certain limitations to that where I'm guessing you're not replicating on the back end volumes, I guess you're just using like iSCSI reconnects, or how does that work? I know that we haven't even really got into the solution, but I know that you're only on certain clouds right now, and I'm assuming that's partly due to the technicals of the limitations of their infrastructure.
Right, exactly. And that's, each cloud has some different kind of quirks, we'll call it, around how they function, what the different, technologies look like around them. I know somebody in the chat had asked about being able to move, larger systems, are the limits around it. And it depends on the use case, right? If you're talking
Yeah.
like spot instances, being able to move from one spot instance to another spot instance in a 2-minute interruption window on AWS, um, depends on how much data. If you're trying to move
Yeah.
120 gigs of data from one to the other, physics is working against you. You don't have enough time in that 2-minute window to get enough through the pipe over to the new system.
Right.
Now, if you're talking small pods, if you're talking less than 32 gig nodes, yeah, you can move that fast enough. 64 gigs, maybe you're kind of on the edge. Depends on how much other network traffic there is tying up the bandwidth. 64 gigs is sort of getting on the edge that you can move in a 2-minute window. Now, that other example that I was talking about those long running Spark streaming jobs, even if they're running on demand, live migration is still a massive benefit because now you can do server upgrades without taking an outage. You can create a new node that's running your new patched version of Kubernetes, running your new patched OS, and be able to migrate the pod from one to the other. Your time to replicate is less important. Even if it takes you 3 minutes to replicate, or 4 minutes or 5 minutes to replicate the memory from one box to the other, who cares? It's not going to be paused for that long because what we're doing is we're doing delta replication. So you
Yeah.
replicate a big chunk, and then you replicate a smaller chunk, and then a smaller chunk, and then a smaller chunk, until the chunk is small enough where you can do it in a pause window. And so now when you're talking moving a huge service from one to the other, same thing if you're talking like NVMe local storage. We've got another customer we're working with, and it's a different set of problems. They have a terabyte of NVMe that they use on local ephemeral disk on every node that needs to be replicated from node to node when they do node upgrades. That takes about 20 minutes, to
Yeah.
replicate all of that from one node to another, even on high throughput disks on high throughput nodes. But if it's happening in the background while everything else is humming along nicely, who cares?
Yeah.
You keep replicating it over, you keep going down to deltas, and then once your deltas get small enough, you pause for 6 to 10 seconds, give or take, depending on how big the service is, and then you slide it over. So a lot of these things are being solved. We're actively reducing these pause times by being able to do more prep behind the scenes, being able to do more processing behind the scenes. Everything is operating as a container D plugin. So I saw somebody asked about on-prem. We will be supporting on-prem. We will be supporting other solutions. The big kind of catch there is everybody has kind of some different flavor of networking and different flavors of things behind the scenes. The actual live migration piece right now could apply to any Kubernetes anywhere. It's specifically the IP stack that gets a little trickier because you've got Cilium running places, you've got Calico running places, you've got VPN,
Yeah.
VPC CNI running places. Everybody has different networking flavors. So being able to maintain network connections when you do the migration is largely the more difficult part of the whole process.
Mm.
Being able to move the pod isn't that bad. So if you've got workloads that you can reestablish connections and the connection resetting is not a big deal, but you don't want to have to restart the pod, that's fairly straightforward. We could pretty much do that today across any container D compatible Kubernetes. It's specifically the networking that causes a lot more hardships because everybody has a different flavor of networking. For AWS, we were able to actually fork the open source AWS Node CNI and create our own flavor of it that now handles the networking piece. So we're using the open source AWS CNI code, and we've modified it, and now it works just fine for our purposes. We're doing something similar on GCP, working with the GCP, if I recall, is using Cilium under the hood for their networking.
Yeah.
So
Okay.
we're going to be building a similar plugin for their Cilium side.
Yeah. And the nice thing is, I guess, if you build it for Cilium, would it work universally across any Cilium deployment in theory? Like, I mean, I'm just thinking of like the most popular CNIs, and if you sort of check those off the list, it sort of suddenly gives you a lot more reach than having to go cloud by cloud or OS by OS, and
Exactly. Yep. In our first iteration of this back in January, February, the first version that we demoed was actually Calico. But a lot of people were like, I don't want to have to rip out my cluster and rebuild it with Calico as the CNI, and we were able to
right.
figure out a way to work with the VPC CNI as a backing basis there. So Calico's pretty much already built. We've got AWS CNI now built. Cilium's our next target. I saw somebody asked about Azure. Azure is probably going to be early 2026. We'll be EKS, GKE, and then we'll work on AKS, and then we'll work on on-prem solutions after that. So on-prem will probably be sometime in 2026.
Nice. Yeah, I can remember, I'm going back again to the 2000s. I can remember when we went from like delayed migrations or like paused migrations to true-ish live migrations. I can remember reading the technical papers coming out of VMware and Microsoft, and they were talking about the idea of these deltas and continually repeating the delta process until you get down to zero, or like you can fit it in a packet and then that's the final packet kind of thing. And I don't know why I remember that all these years later, but I do remember that I thought that was some pretty cool science, like some pretty cool physics across the wire because back then we had, we were lucky if our servers had 1 gigabit. So it was even a bigger, of course, we didn't have 200 gig workloads or anything like that. But this actually led me during my research, and we could talk about the idea that there are attempts in Linux over the years to try to solve this universally. I kind of did some research before the show and saw some projects around ML workloads in particular that a lot of engineers, whether it's platform engineering or just the ML engineers themselves, interested in this because of the sort of the problems of large ML or AI workloads today, where you can't, like you mentioned, you can't interrupt them. If you interrupt them, that you have to basically start over. So that it's sort of a precious workload while it's running, and it might be running a long time. Do you have AI and ML workload customers where are they like maybe part of the first movers to move onto something like this? I don't know. I'm basing it on the KubeCon talks and things that I've seen out there. So.
Yeah, large scale data analytics is definitely one of the big players here. A lot of it's Spark driven data analytics that we're seeing because of exactly that problem. A lot of these jobs will be running for 8, 10, 12, 14, 16 hours, and running those on demand at the scale that they're running them at is extraordinarily expensive. So the big ask is, how do we get those workloads onto spot instances where when we get the interruption notice, we can fall back to some type of like a reserved capacity and then fail back to spot. So basically, the goal is to move to this new concept where in your Kubernetes cluster, you have some like swap space, whether that's, excess spot capacity, 2 or 3 extra nodes of spot capacity, or a couple of nodes of on-demand capacity, where if you get a node interruption, you can quickly swap into those nodes. And then once you stand your new spot instance back up, then you can swap back to that spot instance. That's where we're headed. That's what Q4 is going to be working on this year, is to be able to automate that entire process to where you can float back and forth between kind of some reserve capacity and your spot capacity to really save on those data analytics jobs, those large kind of ML jobs. We're not to the GPU side of things yet. I'd love to get us to where we could live migrate GPU workloads, because that's where kind of the next big bottleneck is going to be. It's just that the hooks aren't there in the NVIDIA tool sets yet, for the CUDA tool sets in a lot of places, to be able to get what we need for data. So we're kind of figuring out our way around that. It's also, they tend to be much, much larger. So the time taken to be able to move them is very, very expensive. It might be 20 minutes to be able to move a job from one to the other, because it took 20 minutes to get it started up in the first place, just due to the size of the models and how much data you have to replicate. So that's sort of we're starting to put some POC work into the GPU side of things while we're continuing on full steam with the building out the expansion of the feature set of the kind of CPU and memory based workloads.
Right. All right. For the audience, I want you to know that we're going to do a demo in a few minutes. We've also got prize drawings at the end and a little quiz we'll do. So at the top of the chat, you should see a link to go sign up for the prizes if you want to go sign up there. We'll be doing a drawing from that database. Dan, I was curious real quick if you've seen on sort of the implementation side of this, there when we talk about these ideas of like the need to live migrate a pod, whether it's for maintenance or and then I almost feel like the next level is the idea of the spot instances, which I love that idea of like my infrastructure is dynamically failing and my applications can handle it. Like I love that. Is there like a maturity level where you see like where people start out and then because it's hard for me to imagine like on day one someone's like, yeah, let's just put it all on spot instances and YOLO, like let's just we don't care, it's all good, live migration will solve it all. Because obviously, like we mentioned, like there are physics limits to the amount of data we can transmit over the wire. Like that's obvious. Like I'm imagining this scenario where you're like accrediting certain workloads, like this replica set is good for spot because it's low data. Like we don't need to transfer 100 gig of data during a 2-minute outage or a 2-minute notice of outage. Like, do you see that like as a maturity scale where you have to implement?
Yeah, I mean,
things
it's absolutely a maturity scale, right? I mean, kind of going back to the references that we talked about, the early days of VMware, nobody started doing vMotion in production, right? I mean, everyone started it. Oh, we've got this, 5-second interruption. Development and test boxes can handle that all day long. So it's the same concept really that we're living in now. We're going through that same evolution. I agree with Phil. I think we're doing it much faster than VMware did in 2002, 2003.
Yeah.
Because fortunately I was around when that happened as well. So
yeah.
I remember living that pain and racking and stacking all those boxes. But yeah, it's very much the same thing. And container live migration is brand new. So we've just been GA for a month or so now with it. So we've had conversations at trade shows and with customers, and there's a lot of excitement around it. I think we're still trying to figure out where it fits, what are the exact workloads that it makes the most sense to do this in. And yeah, I think it's going to be a process of adoption. But yeah, there's definitely a lot of use cases. I think the spot is a very interesting use case, especially the large data models and things that we're processing today. I'm working with a customer now that's doing a lot of video processing in Kubernetes, and that's a very, CPU and memory intensive job. I mean, we're talking a cluster that scales from 80 CPUs to 6,500 CPUs while they're processing this. So there's all these type of scale things that we're really trying to figure out where it makes the most sense to apply this type of technology.
Yeah, and no one wants to have that kind of dynamic scale and then have to pay for reserved instances for all of that, like worst case scenario. That sounds like a billing nightmare. So
well, you don't want a job that runs for hours that costs you tons of money to fail 80% through and have to restart it either. I mean, that's just not efficient. So yeah, I think the ability to really move this and allow those workloads to finish is going to be huge for the market.
Yeah. All right, so we actually have we sort of have been talking a lot about the problem and some of the solution. We do have some slides that maybe give some visualizations for those on YouTube. This will turn into a podcast, so audio listeners, we will try to we'll give you the alt text version of it while we're talking about it. But Philip, I'm just going to throw up your slides on screen because I think it maybe helps with the understanding of exactly what is happening and the process this goes through of how a live migration, like how does it kick off, what's really going on in the background when it starts, that kind of thing.
Absolutely, and we do have some better demos other places I think on the website. Unfortunately, I didn't have the best one pulled up right now, but I could kind of talk through what we have here. Basically what we have is you've got a live migration controller that's looking across all the workloads and all the nodes that are live migration enabled. So to your point, you don't necessarily have to turn this on for everything because not everything, you've got all your stateless workloads. You don't need to live migration to stateless workloads. Just treat them as normal. You've got your stateful workloads that you do want this to use for. So you could set up a specific, node group to be used for that. And that's going to allow you to select what you actually want to do live migration for. You could use it for everything, but it just eats up more network bandwidth and you don't gain as much if you're using it for the stuff that already tolerates being moved. So that controller is going to be looking for different signals within the cluster of when something needs to be live migrated. Spot instance interruption is a good one. Being able to do bin packing, evicting a node from the cluster because it's underutilized, and then migrating those workloads to another node in the cluster. What we call rebalancing. So basically, rebuilding the cluster with a new set of nodes. And that could be because you're doing a node upgrade, you're doing a Kubernetes upgrade, you're doing an OS upgrade. You're just trying to get a more efficient set of nodes. All of those are good reasons that you would want to do your live migration. So what's going to happen in that process is the two daemon sets on the source node and the destination node are going to start talking to each other. They're going to look at the pods on the source node, start synchronizing them over to the destination node. So behind the scenes, all of that kind of memory is being copied over, any disk states being copied over, any TCP/IP connection statuses are being copied over, and you're doing all that prep work behind the scenes. If you have ephemeral data, ephemeral storage on the node, that'll start getting copied. Obviously, depending on how much, it's going to depend on how long it takes. Once the two nodes have identical copies of the data being moved between them, then that's when the live controller will say, okay, now it's time to cut over. And it will cut the connections from one, it'll pause it. And so it'll just put it into a paused state in container D. And then it will unpause on the new node. It'll come up with a new name. Right now we call them just clone one, clone two. We just add clone to them so you can tell which was the before and which was the after. So when that clone one unpauses, the traffic will be going to it. It'll have the same exact IP address that it had while it was on the previous node. All the traffic continues on to that node. It picks up exactly where it left off, and the old pod disappears, right? The old pod gets shut down and torn down. If you have something like a PVC attached, so if you've got an EBS PVC attached, there is a longer pause because you have to do a detach reattach. And that just takes a few seconds with the API calls. It works. It just takes a little bit longer for that pause state. That's just the downfall of having to work with APIs. It takes time to do an unbind rebind to the new node, but it works today. If you're using NFS where you can do a multi-attach, then it's instant. It doesn't actually add any delay. Just NFS is a slower storage technology. So does that sort of make sense from a high level?
Yeah. For those watching on YouTube, I just threw in a poll. I'm actually curious about your CPU utilization. So whether or not your average, if you know your Kubernetes average utilization, throw it in the poll, and we'll talk about that in a little bit. Yeah. So is there, when we talk about like Cast AI as a solution, are there automatic, like does it do live migrations based on certain criteria? Is it making decisions around if you say I want a bin pack all the time? does it in the background, is it just like doing live migrations on your behalf, or is this something where you're largely doing it with humans clicking buttons and like controlling the chaos?
No, this goes kind of back to what we had talked about at the beginning, where automation is key. When a node is underutilized, and I mean, our bin packer that we have embedded in our platform is, I would argue, probably the most sophisticated on the market. It analyzes and runs live tests on every node in the cluster of whether that node can be deleted, whether that node doesn't need to be there anymore. And it'll simulate all the pods being redistributed throughout the cluster. And if the answer is we don't need this node, it would automatically kick off a live migration of all the pods on that node as they redistributed throughout the nodes, and that particular node drains down. Once it's empty, it'll just get garbage collected. And once it's gone, all your pods are already running on the new nodes. Everything's moved seamlessly. You haven't seen any interruption. The cluster keeps continuing on as normal. Same thing with like I said, what we call a rebalance. Most of our customers do scheduled rebalances. So those are things that are just in the background. It's evaluating how efficiently designed the nodes in the cluster are. If the nodes in the cluster are not as efficient as they could be, and different shapes and sizes would be better for that setup at that point in the day based on the mixture of workloads that are there, it'll do a blue-green deployment, set up new nodes, live migrate the workloads to those new nodes, and tear down the old ones. So everything that we're talking about here can either be scheduled or it's automatic. It's running every few minutes on a cycle. But yeah, no, it's entirely seamless to the users.
Nice. Um, we've got some demos to do. We didn't even talk about before the show. We were planning on doing a Minecraft migration with everyone playing. Can we do that?
Yeah, absolutely.
I forgot to discuss it beforehand, but I figured you all are pros and you just had it ready. All right, so this is something we don't normally do, but it's going to be fun. We can see if it'll work, see if it'll pull off with you, the audience. If you're on mobile, this might be a little tricky to watch a YouTube live stream while also doing some stuff in your browser. But if you're on desktop, I know about a quarter of our audience is typically mobile, so you give it your best shot if you'd like. It may not work, but we're gonna throw up. Let's see, put this on screen, and let me see. Can I get the URL? And
I just dropped it in the chat.
Did you already put it in chat? Sorry.
I did. So if people want to jump in, we have a capture the flag, blue team versus red team Minecraft setup, and we will trigger live migrations while people are playing, and you'll be able to watch it. Oh, okay, Brett, maybe you need to put it in chat. Maybe I don't have.
Oh, right, because yeah, you know what? Let me go see if I can approve your message. It doesn't always like other people putting URLs in. Oh, it lost it. It doesn't even tell me. Can you throw it in Zoom?
I can.
And then
done.
Oh. Yeah, YouTube used to let me approve messages with URLs, but now it just like they don't post and it just it goes away in the ether. It falls into the bit bucket. All right, putting this in chat. All right, so we have a tiny URL, and that will bring up Minecraft.
Yep. So it'll come up, and it will look like this.
All right. Is there a way to tell if anyone's connected? I don't actually.
I don't see anybody connected on my side.
I don't run any Minecraft.
We have one
servers.
player on the red team.
Is there? Did I do it wrong? Because mine feels like it doesn't have the IP for it.
We've live migrated twice already. We're on clone 3. All right, we got 2 players on the red team. 3 players. Everybody's on the red team. All right, we need one more player to start, I think.
I just connected as well, so we'll see which team it shows up on.
All right.
Okay, now we're good. We got 5 players. How's it going, Dan?
I'm still playing.
Nice.
Yeah, I'm over here. I think I'm over here. I don't know what I'm doing. I'm following somebody.
So we've live migrated 6 times since we've started signing everything up. So
yeah, and
what we
haven't
normally
seen anything.
see, just for the, I guess the sake of the demo, right, is normally if you migrated this pod basically running this game, it would kick everybody out. You go back to, have to reconnect to the server and all that kind of good stuff. Well, Phil's migrated this 5 or 6 times now with no interruption to the game. So, I mean, it kind of shows how we transfer the state, how we move those workloads, with no interruption to the end users.
Yeah. This goes to show how little I know about Minecraft servers. But hey, it feels like Doom. Friendlier Doom.
It does feel like friendlier Doom.
Oh, someone's saying they got kicked.
I wonder if it's people's corporate networks or something. Maybe they're getting blocked from playing games at work. Yeah, I've seen the teams switching back and forth between blue and red, so I'm not sure with the number of players on each side. Yeah, we've done this at trade shows and stuff before. It's kind of fun.
Yeah. So in the technical details, we're moving the IP address. I think you had a diagram showing like the pod, like it's so on the nodes, like when we get down to the nitty gritty of like Kubernetes level stuff of talking about the pod is recreated, but pod names have to be unique, and you can't have the IP. Well, in theory, you can't have the IP on both nodes at once. And then there's the difference between TCP and UDP and other IP protocols, and there's a lot of little devils in the details that I'm super interested in. We won't have time to obviously go into all of it, but I do remember you showed like the replica, the pod that you're creating. I guess step one is we got to create a pod and download an image, right? Because this is all still going through containerd, so there's not like voodoo magic in the background happening outside of the purview of containerd. So maybe you can talk about that for a minute around the
Right, exactly. So that's exactly
pod
what's
name
happening, is that
changes.
we are. Yep, exactly. So by changing the pod name, you now have a placeholder for your new pod information to go into, and it does actually maintain the same IP address when it moves over from one to the other. So to your point, that's when that basically switch has to kick in, where the old pod definition disappears and the new pod definition appears in your SED in your control plane with the API calls up to your kube API. So that cutover is extremely important because, to your point, you can't have the same pod living in the same place twice. And that's why we do have to change the name when we switch it over, which there's certain services that does cause some tricks to, because they have an operator structure where they expect there to be a certain pod name. So when you move it and you add the clone suffix to it, we're working on finding workarounds to that in certain areas. So that is a little bit tricky on certain workloads because you can't have the same pod existing in this with the same name in two different spots. They have to be unique.
Right.
But yeah, definitely. Yep. Sorry, go ahead.
I was going to say I found your
go.
slide on that,
Okay,
where
good.
showing the name. The IP is the same, but the pod name is going to have a clone-1 or something like that on it, so that it, yeah.
Yep, perfect. I was looking for that. I had the wrong deck up, so
that's okay. So it starts with your pod, and then there's an event that happens outside of the pod that is obviously talking to containerd, and you're sort of adding a second. It's technically a second pod.
Correct. Yeah, it's adding that placeholder, and because the placeholder pod is actually still in a paused state, it can have the same IP address. It's not actually routing traffic to it because it's not an active pod yet. So it'll be kind of in like a staged state. So you stage it up with all the information, but it has to be named differently. And then when you do the cutover, that's when you basically switch it from being inactive to active and switch the old pod to be inactive. And that's kind of the final stage when the clone pod becomes the primary, and because it's maintained the exact IP address within the system, that it's not losing any traffic. So the networking system within Kubernetes just immediately routes it to the new node, and the routing tables are updated, and the pod goes to the new destination.
Yeah, that does sound like the hard part there of like the old pod is shut down so the IP can be released. I assume the IP can't be taken out while that old pod is still active. It's one of these things where it's like, I understand it at the theory level, but I have no idea what containerd and like kube proxy and all these different things that are binding to a virtual interface, and the order of the things that have to happen in the exact right sequence in order for you to first assign that IP to the new node and then also replay all the packets. Like, it does seem like a very discrete order of things that have to happen, and it's not willy-nilly. It has to go in a certain order or it'll just all fail, it feels like.
So that's the part that took us about a year to figure out. There had been a lot of studies, and there was some research papers around the moving of memory and the snapshotting of different workloads. Like, that part was a little bit more straightforward because it was really kind of out of the vMotion playbook days, from early on. There were also some college studies around container using cryo to replicate and migrate containers. None of them had been able to solve the IP side of things, the connectivity side of things. That's what Cast AI was able to solve for. And it took a lot of research, took a lot of in-depth work. We started on this, early 2024 with a team of about 5 engineers. Deep kernel level Linux kernel engineers, Kubernetes engineers, people that were very, very familiar with the code. They contributed to the Kubernetes open source project, and it was 10 months before we had a demo, and that was using Calico. Before we could demo, we had to have a custom AMI at that point in time in AWS because everything was kernel level at the AMI level. We knew that was not feasible going forward to production, but that was the first demoable version of this. Like anything else, right? There's a lot of warts and vaporware in the first version. Since then, we were able to move the logic up to a containerd plugin, makes it a lot more portable. Now it can be applied to different clouds. It's much less invasive. You don't need a specific AMI under the hood anymore. We were able to move it to the AWS VPC CNI, so now you don't need the custom Calico CNI. So all of those were kind of iterative steps through the process of being able to build this and make it more production viable and adoptable by the industry. Now it's a matter of, we've got kind of 2 forks going on. One is continuing to build out additional platforms, figuring out Cilium, figuring out Azure CNI, that path. The other is performance tuning the existing migrations, reducing time to migrate, being able to reduce the size of the deltas down further and further so we can migrate it faster and faster. So we've got kind of those 2 tracks right now. The team's up to, I think, 10 or 12 engineers kind of working on those 2 paths. And this is probably one of our most heavily invested areas in the company is being able to further this technology because we see how much value it brings.
Yeah. I mean, I can imagine that it won't probably be very long where this technology is pretty advanced, but like others eventually will probably, if it's truly the thing that we all are looking for, and it sounds like it feels like it is, like it feels like the kind of tooling where it's a hard problem to solve, and we'll maybe see other people attempt to do it. I mean, the research I had to do for the show, because I was very curious, I was like, what's the history of all this? And someone I think in chat mentioned CRIU, which I believe you're using at least some of that. And that's a project that's been around for quite some time, over a decade, and it's not a new idea. But again, like a lot of these other technologies, it's like the devil's in the details, and we never really had an ability, it sounds like, to really capture and understand what a binary's true dependencies were, whether it's disk or networking things, until we had containers. And then you even mentioned on here, like it's in LXC, it's in Docker, it's in Podman. Like this actually tool is used widely. It's just maybe not well known to us end users because it's packaged as a part of other tooling. And I can sort of see a world where if this becomes more widespread, you're going to kind of end up with haves and have-nots, where my solution doesn't have live migration, or my solution does have live migration, and we're at some point maybe it's ubiquitous, right? Like maybe it's so you're building functionality on top of it, like your automation that really truly adds the value around let's go do spot instances where my company maybe has never done spot instances because it was too risky for us and we didn't have the tooling to even take advantage of it without risking downtime. And I definitely have a couple of clients that I've worked with over the last couple of years that are like that, where like they're 100% reserved instances because they want the cheapest, but they also need to guarantee uptime, and they can't do that at a level that like live migrations would provide. So they have to pay that extra surcharge for avoiding sort of ephemeral instances and stuff like that. So to me, like, it gives me comfort that the technology stack is part open source, part community driven. Also, there's also the product and private IP side of this as well. But it's not like you're reinventing the Linux kernel. It wouldn't have been that long ago where you had to actually throw in a Linux module or kernel module rather that would only work on certain operating system distributions of Linux, and that you would have to deploy a custom ISO. Like that wasn't that far in the past. But now that we've got all these modern things, I don't know if eBPF is involved in this at all, but like we've got more modern abstractions that it feels like sounds like you can just plug and play this sucker as long as you've got the right networking components. And I think that part's just, from an engineering perspective, pretty awesome because it allows you to build stuff on the stack like this. So the team's not on the call, but the team that's developing this, like, good job, bravo. That's some great engineering. Obviously, anytime something is a year-long effort to crack a nut like this, I feel sad for the people that had a 6-month horizon. Like, no one's going to see this feature for a year, and I'm going to work all year on it, and I hope someone likes it. So that's from a software development perspective, that's the hard part. That's the true engineering.
Yeah, absolutely.
We could talk about this forever, but people have their jobs to do. So let's get to some raffle drawings. So if you didn't see this in the 1,000 places I posted it, and as well as the Cast AI team posting all over the place, we're going to do some drawings. And in order to do the drawings, you have to look up at the top of your chat, and there's a link, and you got to go fill it out. But let's just put some people up on screen, and maybe they were waiting to hear. I do believe the team's going to send you an email, since you did have to give us your email address to sign up. So that's the way you'll get notified, rather than us trying to correlate your YouTube name with your email address, which, I've tried to do that before on the live stream, and that is hard. There's not, YouTube doesn't even have DM abilities, so it's not like you can connect to me privately and prove that was your YouTube channel handle. So we don't really have that level of sophistication. All right, so the first person, you're going to get some so the first few that we're going to do, Cast AI is going to send you some swag, including a vest. And I didn't get a vest, so I'm also kind of feeling like I should have signed up for the drawing. Let me put this on screen.
I don't think any of us have a vest either, so all good.
Yeah, I don't have a vest. I've got 4 years worth of. Yeah, I've got 4 years worth of Cast swag, and I don't have a vest. So.
All right, the first one is hopefully I'm pronouncing this right, Shishadri. Sorry if I mispronounced that. I'm going to put it in chat. It's because you wear the blue top that you didn't get the vest. Yeah. Back when we were early days of Docker Captains, the captains got swag that the engineers that worked at Docker were always jealous of. So I felt kind of lucky being one of those early people and getting some special swag. They had swag we didn't get either, so it was kind of like, pick your poison. But all right, so that's the first one. The next one is going to be Keith. Keith, if you're out there, congrats. Next up, this is for another vest. All right, Duncan. You're getting a vest. Again, you probably should get emails for these. And then Okay, so the drum roll. I was actually looking up a drum roll sound earlier because I have a drums, but it's the wrong kind of drums. I don't have drum roll technically. So for the AirPods, which I also want and was hoping that I would somehow get a set of these. The AirPod Pros 3 go to David. What's up, David? Hope you're out there listening. Congrats. You will be getting emails from the Cast AI team. And I think according to this, that's a pretty worldwide list of people. I'm looking at some of their data that I will not put on screen. But yeah, they're all over the place. So congrats for those of you who showed up for the prize drawings. Sorry if you weren't a winner. I was not a winner either. But okay, how do people get started real quick? How do they, do they just go sign up for Cast AI and this is like a feature out of the box that they can implement in their clusters or?
Yep, absolutely. It's GA, it's in the UI now. So if people want to go sign up and onboard, we do recommend having somebody on our sales engineering team work with folks. So reach out to us. We'll also reach out when people sign up as well. But yeah, no, it's all straightforward. There's no kind of caveats. It's Helm charts to do the install, and then you set up the autoscaler. We will be adding support for Carpenter. Today it's using our autoscaler, but we will support Carpenter. I think around end of Q4 or early Q1, we're going to be supporting Carpenter instead of our own autoscaler. So,
yeah, that's great. My usual co-host Normal is with AWS, so they would greatly appreciate that. And I know that we've definitely over the last year, I think Carpenter's been out, I don't know, a little over a year. We've had a surprising number of people on our Discord server. For those of you watching, it's over there above Dan. There's a Discord server you can join. There's a lot of people that seem like on Discord, as well as other people we're talking about that on the show that talk about using Carpenter. So I'm actually really impressed with what the uptake has been on that project. And in case you're watching and you're wondering what the heck Carpenter is, it's with a K, and it's for Kubernetes. And you can go look on this YouTube channel later because we did a show on it and had people talking about it on the show and demoing it whenever it was released. I think that was 2024. I can't remember exactly. All right, so everyone knows how to get started. Everyone now knows that they wish they had live migrations, and they currently don't unless they're a Cast AI customer. I think that's it. Gentlemen, where can we find you on the internet? Where can people learn more about what you're doing? Are you going to be at conferences soon? I'm assuming, Cast AI is probably going to have a booth at KubeCon again. They always seem to have a booth there.
Yep, we've got a big booth at KubeCon this year. I think we've got a 20 by 20. We're going to be doing demos and presentations in the booth. This is going to be a big part of that. We'll also be at reInvent in Vegas in early December, I guess it is, first week of December. So I'll be at both of those events. Dan, are you going to be? Which ones are you going to?
I'll be at KubeCon. I think that's the only other big conference I have this year is KubeCon. So
okay, so Dan will be at KubeCon. I'll be at both.
I get to miss out Vegas.
Missing out on Vegas. It gets tiring. I've been to Vegas so many times.
It's so old.
It gets old after 10 or 12 times. And then I'm also really active on LinkedIn. So if anybody wants to reach out to me on LinkedIn, if you want to set up a session just to go into more detail, feel free to ping me on LinkedIn. I post a lot of content, just Kubernetes content in general, best practices, things that we see in the industry from Kubernetes evolution side of things, and also obviously a bunch of cast stuff. So, feel free to just follow me or connect on LinkedIn. Happy to share more information with people.
Awesome. Well, I'm looking forward to hearing about that continual proliferation of all things live migration on every possible setup. Someday it'll be on FreeBSD with some esoteric Kubernetes variant. But we'll get there. I get there. It's pretty cool to see the evolution of this. Well, thank you both for being here, Philip and Dan. I'm expecting my swag any day now from you. I appreciate you sending it to me. Thank you so much. Otherwise, I will have to pick it up some more at the booth, like I try to do every year. And I will see at least one of you at KubeCon. And those of you that are going to KubeCon, in case you didn't know, we actually try to organize meetups at all the conferences. So if you're going to be at KubeCon or in Las Vegas or any of these other ones, if you go to the Discord server, again, above Dan, we actually have a dedicated conference room in there. Since we have enough people in the Discord now, we do meet and greets where we hang out, we take selfies, we go to a meal sometimes, and that's a fun part of just meeting other people in real world that have also watched us online and have had an unusual amount of hours of watching me in courses is always a joy. So I'm encouraging all of you to go there and tell us you're going to be at the conference, and then we will all meet up at the conference and learn about each other and talk about live migrations that we may or may not have yet because we haven't adopted Cast AI. All right. Thanks you all for being here. We'll see you on the next live stream. So this is a usual YouTube thing on Tuesday or on Thursdays. And then this episode will be on our podcast. You can rewind all the way to the beginning to learn about the podcasts and where this will show up later in audio and video formats because I have a fancy editor. Thanks, Christy, for editing. I appreciate you. Hopefully it wasn't too hard this time. I think we did it right. I think we did it good. All right. See you all later. Ciao.